Alright, so, yes, everyone grabs a unit circle, correct?
Yeah.
Everyone has one of these yellow unit circles, and they put their name on it and only their name. Because if you lose it, I'm going to be very upset.
Hey, Mr. Elton.
If you put anything on here that I tell you that... Okay. If you put anything on here that I didn't tell you can put on here, I will tear it up and give you a blank one on test day.
Oh.
You can only put what we tell you on here. Right? You will be able to use this on your test. Anything that we tell you that you can put on here, you can use on your test. Anything extra, we'll get it torn up and thrown away. Is that understood?
That sounds good.
Alright, that includes pictures. Do not be doodling pictures on here.
So if I draw a smiley face.
If you draw a smiley face, I will tear it up and throw it away and give you a blank one. Seriously.
You're bluffing.
Because I'm a big, mean person. That's why.
You're right. I'm calling your bluff.
Okay, let's see how that works for you, Eileen.
Alright.
Alright, so, anything in red you can write on there.
Oh gosh.
I'll give you a couple minutes just to write it on there and then we'll talk about it. Because I don't want to explain it while you're writing and you're not paying attention. So anything in red you can write on your unit circle. And then I'll go through and explain it.
Can the person who's watching see the screen?
I sure hope so. Otherwise they wouldn't be very good for them to be watching it. They miss all the important stuff.
You can write whatever you want on your sheet.
Thanks, Kevin.
Trevin the troublemaker.
He didn't get it.
That was your chance to sell them on the Girl Scout gum.
No, we'll not have any sales pitches today.
I don't know what you're talking
Thin mint gum.
about. No, I don't.
He's accepted it was a bad idea.
Yeah.
Now he's trying to pretend it never
Good.
happened.
The house in Georgia wasn't a great idea either.
I don't know. I think that's a good idea.
$90,000.
I've never
12
seen a
bedroom.
15-room box before.
It didn't look good.
So wait, how can it just be 1 over sin and not a number following
It
sin?
literally did not.
We'll talk about it. Alright? Just write it down right now. If you notice there's stuff in the bottom right hand corner as well, it says 2 pi equals. It's just the different variations. Like 6 pi over 3 can be reduced to 2 pi. 8 pi over 4 can be reduced to 2 pi. 12 pi over 6 can be reduced to 2 pi. If you want to add 4 pi over 2, you can as well. Any of those variations of 2 pi. So we will deal with radians a little bit. They are a little bit nicer to work with, I think, and it makes it a little bit quicker than changing everything to degrees. You guys can make that decision on your own. Yes, Trevin?
The thing in the bottom right, is that something you can write?
I mean, it's something you can write. You don't have to. If you know that 6 pi over 3 equals 2 pi, then you don't need to write it. But you can put it on there if you want. Yes, Paige? Yes, I can. So, where did you go to get 30? Okay, so you want negative 480, right? So how far from, so we did, you went around 360. And how far did you go from there? After that? Okay. So if I know from, how far is it from here to here?
I love school.
From here to here. 90, right?
Oh yeah.
So if this is 30, that's going to be 60. That's why that's a reference. Okay? It's the terminal side, the x-axis. The nearest x-axis.
Mr. E, you
Yep.
took the
I did, because people kept putting silly names up there that didn't exist, and
Where?
they weren't making it any fun, so.
Yeah, silly names like Tommy Dre's.
I
Who
was just
exists
trying to be a nice
besides silly
person.
names?
Alright, here we go. Since everyone's talking, I think we're done.
No, we aren't.
On your unit circle, you will notice there are things on there that we didn't see yesterday, right? There's coordinate points, ordered pairs, a bunch of weird numbers in those ordered pairs, right? Where do you think all those things come from? We talked about it yesterday a little bit. Where do all these ordered pairs come from, you think? They come from those special right triangles we were talking about, right? In pre-calc FST, you guys will make it. You'll find out where all those numbers come from. But each ordered pair is the cosine, comma, the sine for that angle. So in this case, if I look at 60 degrees, the cosine of 60 degrees is the x value. It's 1/2. The cosine, or excuse me, the sine of 60 degrees is the y value. It's square root of 3 over 2. That's why we say cosine theta equals x, sine theta equals y. Alright, so you need to look at the x value of the ordered pair for cosine, the y value of the ordered pair for sine. Tangent, we know, is sine over cosine. So that means it's going to be y over x. I'm going to write it a lot like y divided by x. Because we're dealing with fractions a lot, I'm going to write it out as y divided by x. And then those 3 on the right are all just the reciprocals. So cosecant of theta is the same as 1 over sine of theta. Right? Secant of theta is equal to 1 over cosine of theta. So I know sine is y, so if it's 1 over sine, it's going to be 1 over y. If it's secant, it's 1 over cosine. Well, cosine is x, so if it's 1 over cosine, it's 1 over x. Alright, that makes a little more sense when we do more examples, but that's what all this means. Cotangent is the reciprocal of tangent. Alright? Any questions so far? Alright, let's try some problems. So what we're going to do is we're going to ask you to evaluate the following using the unit circle, not your calculator. So I don't want you to go and punch cosine of 315 in your calculator. That's going to give you a decimal. I don't want a decimal. I want an exact ratio. So, cosine of 315 degrees. If I look at cosine on my unit circle here, it is what in terms of x and y? Cosine theta equals x, right? So I'm going to look at the x value at 315 degrees. Yes?
I don't see these problems on my sheet.
On your homework? Or excuse me, on your note packet?
John.
Should be on your note packet. Day 2. So,
Okay.
if I go to my unit circle at 315 degrees, so I'm going to find 315 degrees on here, it's right here. I said I want the x value. So I'm going to look at the ordered pair. The x value is square root of 2 over 2. So, square root of 2 over 2. That's my answer. That wasn't too bad, right? Alright, let's try the next one. Cosine of negative 210 degrees. Now you can use negative degrees if you want, negative 210. Start at 360, count backwards. Or you can change it to a positive value. Right? I know negative 210 degrees is just 360 minus 210, which is going to equal 150 degrees. So I can do either cosine of negative 210 degrees, or I can do cosine of 150 degrees. So, cosine. Cosine is what in terms of x and y? X. So I want the x value at 150 degrees. So I'm going to go up here. 150 degrees. Look at the coordinate, the ordered pair. I want the x value. So it's negative square root of 3 over 2. That wasn't so bad.
Nope.
Alright, let's keep going. Cosecant of negative 240 degrees. Same thing, I'm going to make it a positive degree value. So 360 minus 240 is going to give me 120 degrees. So I get cosecant of 120 degrees. Well, in terms of x and y, what is cosecant?
1 over y.
1 over y, so it's 1 over the sine. So 1 over y. Now, I'm going to find y first, because I need it, right? So y equals, I'm going to go to 120 degrees. 120 degrees on my unit circle. I want the y value. Square root of 3 over 2. So the y value there is square root of 3 over 2. Now, I'm not looking for y though. I want 1 over y, or I want the reciprocal of y. So, if I want 1 over y, what should I do to square root of 3 over 2?
Flip it.
Flip it, right? I took the reciprocal. So, 2 over square root of 3. And Eileen, you used a great word there, what was it?
Rational.
Rationalize it, right? I don't want that square root in my denominator. So, times square root of 3 over square root of 3. So my final answer, I'm going to put it down here so I can leave myself room. 2 square roots of 3 over 3. Still not too bad, right? We're good yet? We're good? Any questions? All right. Fourth one, tangent at 210 degrees. It's a positive degree measure. I'm okay with that. Tangent in terms of x and y is what?
Y over X.
Y over x. I'm going to write it as y divided by x. So I'm going to be dealing with fractions. I'm going to just write it like that. So 210 degrees. Look at my unit circle up here. 210 degrees. I want y divided by x. So I want negative 1/2 divided by negative square root of 3 over 2. How do I divide fractions?
You have to keep
Multiply the reciprocal.
Multiply the reciprocal or keep, change, flip. Right, so negative 1/2 I'm keeping. Change, or division to multiplication. Flip the last one, 2 over negative square root of 3. And then I can just multiply top, multiply the bottoms. Negative 1 times 2 is negative 2. Over 2 times negative square root of 3 is negative 2 square root of 3. Now before I worry about rationalizing it, I'm going to simplify it. Right? I have a negative 2 on top and bottom. Negative over negative is positive. I can take a 2 out of both of those. Make it 1 square root of 3. Then I have to rationalize. So 1 over square root of 3 is, I multiply by square root of 3 over 3, square root of 3. I get square root of 3 over 3. Any questions?
No.
That wasn't so bad, was it?
No. We
No.
don't need more examples.
Alright. A few more. Now we're talking about radians. Now we're talking in terms of radians. I'm going to skip the first one right away. I'm going to do the second one first. We'll go back to it, I promise. Alright? First one I'm going to do, we're going to stick in radians. The second one, we'll go back here and we'll change it to degrees. Otherwise we can decide what we want to do from there. Alright? So the first one, 23 pi over 6. Can you find that in a unit circle? Not on there, is it? No. So, I need to reduce it. 23 pi over 6. So I know if I go 540 degrees around, I can take 360 off, because that's all the way around the circle, right?
Where'd you get 540?
I just picked a number. I'm just talking. If we have 540 degrees, I can take off 360, because that's all the way around the circle once. I'm back to my starting point, right?
Yeah.
If I'm talking in radians, how far is it around the circle?
But
2 pi, right? So, I want to take off 2 pi. But if I'm going to take it off and I'm using a fraction with a denominator of 6, 2 pi equals what over 6? 12 pi over 6. So what I'm going to do is I'm going to subtract 12 pi over 6. Alright, so I'm taking off a full time around the circle. So this is the same as going around the circle one whole time. I'm left with 11 pi over 6. Is that on my unit circle? Yes, it is. So I can use that one. So I know I'm going to do the secant of 11 pi over 6. Well, secant has got to be 1 over x. So I'm going to find my x value. Right, I'm going to find the x value at 11 pi over 6. So 11 pi over 6, 330 degrees. The x value is square root of 3 over 2. So if I want the reciprocal of that, or I want 1 over x, I'm just going to flip my fraction. 2 over square root of 3. And then what do I have to do to that? I need to rationalize it. So times square root of 3 over square root of 3. I get 2 square roots of 3 over 3. Alright? So that's my final answer. It's just like using degrees when we subtract off 360. So we know we're going around a full time. You need to subtract off in radians what it would be going around a whole time. That wasn't too terrible, was it? No. Let's go back into the first one. But in this case, what we're going to do is we're going to change it to degrees. It's going to take a little bit longer. There's going to be a lot more calculations, a lot more room for error. You can change it to degrees every single time if you want. I have no problem with that. But you need to be careful when you do it. Punching things into your calculator could happen incorrectly. Simplifying can happen incorrectly. You just have to be careful when you change it to degrees. Alright, I don't care if you do. You just got to be careful. Yes, Trevin?
Wait, so why did you say 2 pi again?
2 pi, because I know, just like going around my circle one time in degrees is 360 degrees, going around it one time in radians is equal to 2 pi. Alright? Yes, Jalen?
Why did we need, for number 6, why did we have to subtract the 1 radian in order to...
Why do we subtract 12 pi over 6?
Yeah,
Because can you find 23 pi over 6 on your unit circle?
no.
No. So we subtract going around one whole time to see how far we have to go yet. Because we know if I go around one whole time, I still have 11 pi over 6 to go. And I can find that on my unit circle.
So 1 radian equals 360 degrees?
Not necessarily, no. 2 pi radians equals 360 degrees.
Okay.
Alright? Alright, so this one, let's do it where we change it to degrees. It's going to take a little bit longer, a little bit more work. We got to be careful. So I'm going to take negative 17 pi over 6 times. To change it to degrees, I'm going to do 180 over pi. So those cancel. I get negative 3060 divided by 6, which is going to give me negative 510 degrees. Right? So I changed it to degrees, I got negative 510 degrees. Now, just like with radians, that's more than one time around the circle. So I'm going to take 360 off of it, so I know if I take that off, it's just like I came back to 0. Alright, so if I take 360 off, in this case it's technically adding 360 because it's a negative, I'm going to be left with negative 150 degrees. Now, once again, I don't want to deal with a negative degree when I do my unit circle. You can, that's perfectly fine, but I don't want to deal with it. So I'm going to do 360 minus 150 is equal to 210 degrees. Alright? So what I want to do is I want to do the sine of 210 degrees. Do we all follow me so far?
Yes.
I didn't lose anyone, did I? Alright. So sine in terms of x and y is what page?
Huh?
What is sine in terms of x and y?
Why?
Y. So I'm looking for the y value at 210 degrees. So at 210 degrees, I'm looking for the y value. It's negative 1/2. Alright? Now, my first class, like to change them to degrees. My second class, like to stick in radians. I don't care what you guys do. Whatever you feel comfortable doing, do it that way. Just if you're changing it to degrees, be careful. Alright, make sure we're doing our calculations correct. If we do one, and we get a degree measure that's not on our unit circle,
It's wrong.
you probably did it wrong, right? I'd probably try it again. Alright, so just be careful. What do we want to do? Do we want to do it in radians or degrees?
Degrees.
Radians.
Degrees.
We'll do
Degrees.
we'll do one in degrees and one in radians. How about that?
Okay.
Alright, we'll compromise. So, we'll do the first one in radians. Alright? Cosecant 17 pi over 3. So if I have 17 pi over 3, and I want to subtract off 2 pi. Well, 2 pi is equal to what over 3?
6.
6.
6 pi over 3. So I'm going to subtract off 6 pi over 3. Well, that's going to give me 11 pi over 3. Right? Can I find that on my unit circle?
No.
No. Got to do it again, right? It's around more than one time. So minus 6 pi over 3. It's going to give me 5 pi over 3. Can I find that on my unit circle?
Yes.
Yes. So I'm going to do the cosecant of 5 pi over 3. So, cosecant. Cosecant in terms of x and y is going to be 1 over y, or 1 over the sine. So, I need to find out what y equals at 5 pi over 3. Well, if I look up here, 5 pi over 3, it's going to be right here at 300 degrees. I said I wanted the y value. So the y value is negative square root of 3 over 2. So negative square root of 3 over 2 is equal to y, which means 1 over y is going to equal what? 2 over what? Negative square root of 3, right? So 2 over negative square root of 3, and then I need to rationalize it. So it's square root of 3 over square root of 3, I get 2 square roots of 3 over negative 3. Or if you want to move that negative up to the top, you get negative 2 square roots of 3 over 3. Either way is fine. Alright? Any questions?
No.
No. Alright, then, we have one more to do. One more. We're change to degrees?
Yes.
Yeah? Alright. So we start out with negative 13 pi over 4. Multiply it by 180 over pi to change into degrees. So my pi's are going to cancel. What's negative 13 times 180? Anyone?
Negative 2340.
What?
Negative 2340.
Negative 2340 divided by 4 gives me what?
500.
Negative 585. Okay, so negative 585. That's my degree measure. Now that's bigger than 360, right? So I'm going to take 360 off of it. Add 360. I get negative 225 degrees. So, once again, I don't want to deal with the negative. So I'm going to take 360 minus 225. I want to get the positive version of that angle, or that degree measure. So 360 minus 225 should give me 135. So positive 135 degrees. So the last one I'm going to do here is going to be cotangent of 135 degrees. Well, in terms of x and y, what is cotangent? X over y, or x divided by y. So at 135 degrees, I need to find out what my x and y values will be. 135 degrees right here. I want my x value, negative square root of 2 over 2, divided by my y value, square root of 2 over 2. So, negative square root of 2 over 2, divided by square root of 2 over 2. What? What do I do? Hannah, what do I do?
No, I'm fine. Keep change flip.
Keep, change, flip. Multiply by the reciprocal. Negative, oops. Negative square root of 2 over 2 times 2 over square root of 2. That'll give me negative 2 square roots of 2 over 2 square roots of 2. What does that equal? Negative 1, right? So negative on top of positive, same number. Negative 1. Yes, Tommy?
C, D, E, and F just went out on that.
Did they? They happen sometimes. I don't know why. Any questions on that? Yes, no, maybe so? Nothing? Alright, 2 problems left. These ones are a little bit different. What do you notice about them?
Oh.
We're going to go backwards, right? We're given the answer. We're told secant theta equals 2. And I want you to find the angle measure, or the degree measure, or the radian measure that would make theta be true. So, what is secant theta in terms of x and y?
1 over x.
It's 1 over x, right? So if secant theta is 1 over x better equal 2 as well. Well, I know 1 over x is the reciprocal of x. So, I want to know what x equals. What?
1/2.
1/2, right? If I take the reciprocal of 1 over x, I better take the reciprocal of 2 over 1. So I want to know what I need to find. is when does x equal 1/2? So let's look at our unit circle. Anytime one of those ordered pairs has an x that equals 1/2. Oh, 60 degrees works. Keep looking.
300.
300 degrees works. Yes, you need to put both of them. So how I'm going to write it is I'm just going to go down here. I'm going to write them down 60 degrees, which is also pi over 3. Yes, you have to have the radian measure as well. And then 300 degrees, which is 5 pi over 3. That's my answer. I just want to know when those things happen. When does x equal 1/2? Alright? Should we do the last one? Are we good to go?
Yeah.
Okay. So make sure I'm not losing anyone. Cosine is equal to x. It equals negative square root of 2 over 2. So I need to find on my unit circle, where does x equal negative square root of 2 over 2? So I'm going to look. Negative square root of 2 over 2. Negative square, oops. Negative square root of 2 over 2. So I found my two spots. I know it's going to be at 135 degrees, or 3 pi over 4, and 225 degrees, which is 5 pi over 4. Alright? Any questions?
No.
Stuff wasn't too bad, was it? We're doing more of that stuff tomorrow. We're good to go.
Bye bye.